Namaste students. We are moving on to a new chapter, trigonometry. The word trigonometry can be split into three parts: trigonometry. Tri means three, gono means angle, metry means measurement. So it is a three-angle measurement. Some authors use this gono as side. So it can be said as three-side measurement also. Never mind, the concept is it's a study of triangles which has three sides and three angles. Trigonometry gives you the relation between sides and angles of any triangle. So as this is the introduction stage, we will be discussing only right-angled triangle in class 10. Consider this right-angled triangle ABC, right-angled at B. So AC will be the hypotenuse, which is the longer side of the triangle and opposite to angle 90 degrees. So let this angle C be theta. This is theta. I have missed it in the diagram. So let this angle be theta. The side which is opposite to this angle is known as opposite, and the side which is adjacent to this angle is known as adjacent. We have two sides which are adjacent to this angle C. One will be hypotenuse, which will be the longer side of the triangle, and the other will be the adjacent. So we have six trigonometric ratios. These six ratios are the basics of trigonometry. So these are the six trigonometric ratios. So these ratios are given by comparison of any two sides of this triangle. So we have three sides here: opposite, adjacent, and hypotenuse. Comparison of any two sides: opposite by hypotenuse, hypotenuse by opposite, adjacent by hypotenuse, hypotenuse by adjacent, opposite by adjacent, adjacent by opposite. So these are the six possible ratios which are given by six trigonometric ratios. We'll see one by one. So this is sine theta, in short written as sin theta. This is cosine theta, in short cos theta. This is tangent theta, in short known as tan theta. This is secant theta, in short known as sec theta, but we'll pronounce it as secant theta. This is cosecant theta, we'll write it as cosec theta, but we pronounce as cosecant theta only. So secant and cosecant will be pronounced as it is. The other things we use short form for the pronunciation. So this is cotangent theta, in short known as cot theta. So these six trigonometric ratios are given by sine theta is given by opposite by hypotenuse, and cosecant theta is given by hypotenuse divided by opposite. So you can see a relation between sine theta and cosecant theta, which is cosecant theta is the reciprocal of sine theta. So you can say that cosecant theta is equal to 1 by sine theta, which is why these two are given in the same color. So similarly, cos theta is equal to adjacent by hypotenuse, whereas secant theta is given by hypotenuse by adjacent. So both are reciprocals of each other. So secant theta is equal to 1 by cos theta, or cos theta is equal to 1 by secant theta, both are same. And tan theta is equal to opposite by adjacent, and cot theta is equal to adjacent divided by opposite. Again, you can see the relation between tan and cot. So cot theta is equal to 1 by tan theta, or tan theta is equal to 1 by cot theta. And tan theta can also be given by sin theta by cos theta. So we know that sin theta is equal to opposite divided by hypotenuse, and cos theta is equal to adjacent divided by hypotenuse. So opposite divided by hypotenuse, the whole divided by adjacent divided by hypotenuse. Both the denominators gets cancelled. So we have opposite divided by adjacent, which is tan theta. So similarly, you can say cot theta is equal to cos theta by sin theta, which is reciprocal of tan theta. Again, you can have cos theta by sin theta as adjacent by hypotenuse divided by opposite by hypotenuse. Again, both the hypotenuse gets cancelled. You will have adjacent divided by opposite, which is cot theta. Pythagoras theorem plays a vital role in trigonometry, which states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Here the other two sides are opposite and adjacent. Therefore, hypotenuse square is equal to opposite square plus adjacent square. We have identities based on this theorem, which we'll be seeing in the later in this chapter. So we'll move on to the exercise. Exercise 8.1. First question. In triangle, right angled at B, in triangle ABC, right angled at B, AB is equal to 24 centimeter, BC is equal to 7 centimeter. Determine sin A cos A, sin C cos C. So first thing in trigonometry is whenever you are seeing a question, you have to take the data from that question and represent that data in a neat diagram. So this will give you a clear idea on what is given and what is being asked. So first we'll be drawing a right angled triangle ABC, right angled at B as stated in the question. So we have two informations about this. AB is equal to 24 centimeter and BC is equal to 7 centimeter. So AB is 24 centimeter and BC is 7 centimeter. So we have to find the hypotenuse here. So by Pythagoras theorem, we have AC square is equal to AB square plus BC square. Hypotenuse square is equal to opposite square plus adjacent square. Or AC is equal to square root of AB square plus BC square. 24 square plus 7 square, which is 24 square 576 plus 7 square 49, 576 plus 49 625. Square root of 625 is 25. So AC is equal to 25 centimeter. So by using Pythagoras theorem, we have found the hypotenuse of the triangle. So first subdivision, we have to find sin A and cos A. So check the angle here. So this is angle A. So the side which is opposite to this angle is opposite. The side which is adjacent to this angle is adjacent 24. And this will be the longer side of the triangle, which is 25 hypotenuse. So we know that sin A is given by opposite divided by hypotenuse. So which is opposite of angle A? 7, which is hypotenuse 25. So 7 by 25 is the ratio sin. And cos A is given by adjacent divided by hypotenuse. Again, this is the angle. So this will be your adjacent side. 24 divided by hypotenuse will never change, 25. So 24 divided by 25. Then in second subdivision, we have to find sin C and cos C. So find the angle C in the diagram. So this is angle C. So the side which is opposite to this angle is AB. So this is opposite and this is adjacent. So for angle A, BC is opposite and AB is adjacent. Whereas for angle C, AB is opposite and BC is adjacent. So sin C is given by 24 divided by 25 and cos C is given by adjacent by hypotenuse, which is 7 divided by 25. You can see a relation between angle A and angle C. So sin A is equal to cos C. Sin A is equal to 7 by 25 and cos C is equal to 7 by 25. So this is because in a right angled triangle, in any triangle, we know that the sum of all three angles is 180 degrees. So we know that this angle is 90 degrees. Therefore, sum of angle A and angle C should be 90 degrees, right? So consider let this angle be 30 degrees. So what will be this angle? This is 90, this is 30. So this should be 60, right? Such that sum of all the angles is 180 degrees. So we can say that sum of these two angles is 90 degrees, which means 30 plus 60 is 90. Consider this as 40 degrees. Then this will be 50 degrees. So how we are finding this one is, if this is theta, this angle will be 90 minus theta, which means if angle A is theta, then angle C is 90 minus theta. So can we say that angle A and angle C are complement of each other? Yes, it is. So that is why cosine, which is cosine is known as, is given that name. So cosine actually represents complement of sine theta. So sine theta is 7 by 25 and complement of sine theta cos C is also 7 by 25. So this is angle A and complement of angle A is angle C. So for angle A, sine theta is 7 by 25 For its complement angle, angle C, cosine theta, complement of sine theta is 7 by 25. So this is the name reason for cosine theta. So similarly, we have secant theta, and complement of secant theta is cosecant theta, and tangent theta, this is complement of tangent theta, cotangent theta. We'll be seeing this in detail in the next week. This is just an introduction part about that. So we have found both the solutions. Moving on to the second question. A diagram is given as shown, and we have to find tan P and cot R. So we have PQ is equal to 12 centimeter, PR is equal to 13 centimeter. So by Pythagoras theorem, we can find QR. So PR square is equal to PQ square plus QR square, or QR square is equal to PR square minus PQ square. I am taking this PQ square to the other side, so it becomes minus PQ square. So the remaining is QR square. Or QR is equal to square root of PQ square minus, PR square minus PQ square, which is square root of 13 square minus 12 square. 13 square 169, 12 square 144, which is root of 25, which is 5. So QR is 5 centimeters. So 5, 12 and 13 are the three sides. So we have to find tan P and cot R. So where is the angle P here? So this is angle P. The side which is opposite is this one, and adjacent is this one. So opposite is QR. QR is equal to 5. Adjacent is PQ. PQ is equal to 12. Therefore, opposite by adjacent is given by 5 divided by 12. Whereas cot R, we can see the angle R here. So the side which is opposite is 12 centimeter PQ, and the adjacent side is QR, which is 5 centimeter. So again we have adjacent divided by opposite, which is 5 divided by 12. So here you can see tan P is equal to cot R. This is again because these two angles are complement of each other. So this is angle P, this is angle R. Angle R is complement of angle P. So tan P will be equal to complement of tan R. So adjacent divided by opposite, 5 by 12. Third and fourth question, I want you to try it on yourself based on these steps. The thing is, first thing you have to draw the diagram and take the data and put it in the diagram neatly. Find the third side, you will get all the ratios. We'll see one sum with that. Fifth question. Given secant theta is equal to 13 by 12, calculate all other trigonometric ratios. We'll be finding all the other trigonometric ratios here. By Pythagoras theorem, we have to find the third side. First, we'll have to draw a right angle triangle. Let this triangle be ABC. So let this angle be theta. It is given that secant theta is equal to 13 by 12. So from the trigonometric ratios, we know that secant theta is equal to 1 by cos theta. So we know that cos theta is equal to adjacent by hypotenuse. Therefore, secant theta is hypotenuse by adjacent. So hypotenuse is 13, adjacent is 12. So we know two sides. We can find the third side using the Pythagoras theorem. So AB is equal to 5 centimeters. So we know all the three sides now. So we have to find the remaining trigonometric ratios. We know secant theta. We have to find sin theta, cos theta, tan theta, cosecant theta, and cot theta. So sin theta is equal to opposite by hypotenuse, which is 5 divided by 13. Cosine theta, adjacent divided by hypotenuse, 12 divided by 13. And tan theta is given by opposite divided by adjacent. Opposite is 5 divided by adjacent is 12. Cosecant theta, which is the reciprocal of sin theta. So sin theta is 5 by 13. Therefore, cosecant theta is 13 by 5. So we can say cosecant theta is equal to hypotenuse divided by opposite. Still we will get 13 divided by 5. Hypotenuse is 13 and opposite is 5. Cot theta is adjacent divided by opposite. Adjacent is 12, opposite is 5. So 12 divided by 5. Or you can say cot theta is equal to reciprocal of tan theta. So since we have tan theta is equal to 5 by 12, cot theta will be 12 by 5. So by knowing one trigonometric ratio, we can find all the 6 trigonometric ratios. So with this concept, you can do third one and fourth one on your own. Make sure what angle is asked. If angle A is asked, BC will be the opposite side and AB will be the adjacency. So be careful on what angle is being used.